Hello everyone, this is Preet Kanwal. I'm a lecturer at Mehchan Polytechnic College, Jalandhar. Today I'm here to share with you an important information related to Mission Fateh, that is a campaign run by our worthy Chief Minister of Punjab, Captain Amrinder Singh, who says that we should fight against this coronavirus by taking some small precautions to wash our hands regularly, then to use mask, then to use sanitizer while we go out, and avoid meeting lot of people, that is to maintain the social distancing. So let's move on to the topic, that is programmable logic controllers. As in the last lecture we discussed about the basic concept of the PLC, about the limitations of the relays, and then after we discussed about the basic starting points, the basic introduction of the programmable logic controller, that how it is different from the used normal PCs and how it is helpful in the industrial area or industrial automation. So in today's lecture we will discuss about the main building blocks of the PLC, that how it is being made and how it will work. So let's move on. So I hope you all are clear with this. This is visible to you all, right? This is the PLC. As in the last lecture we discussed about the PLC is having some inputs and some output devices connected, and we can use those inputs and outputs inside in with respect to this PLC. Now we will discuss about how the PLC is working, what is inside the PLC, what is to be connected from the outside. This is all about this basic building blocks of the PLC. So first of all, we are having in the basic building blocks of PLC, we are having input module, output module, CPU, memory, programming device, and the power supply. So total 6 number of blocks are here in this basic building blocks of the PLC, the basic structure of the PLC. So if we will talk about the input, as I have already discussed in the last lecture, we will talk about the input. We are having, say, push button here. The push button, we will push the switch. It is like a switch, right? Then there is a limit switch. If we need to switch it on, we can on it. If we need to switch it off, we can off it. The push button will work whenever we will push it on. When we will push, it will connect to the input. We will not, if we will not push it, then it will not be connected to the input. So here it is, 2 push buttons are connected over here, 2 limit switches are connected. So similarly, some sensors also could be connected. Anything could be connected with respect to these switches inside. At the input side we are having these switches, and at the input of these switches we could connect anything that we need to give as an input to the PLC, whether it is a sensor or whether it is anything that you want to control, right? These are the field inputs basically. Then when we talk about this output module, let's talk about the output module first. We will talk about the output module. At the output side, here you can see we have connected the lamp and the contactor, but along with that we are having numerous of options. We can connect motor, solenoids, bulbs, buzzers, anything that you want to control, that you want to have the output at, we can control, we can connect it with the output module of the PLC. Now if we will talk about the power supply, then this power supply section is basically for providing the supply to all the modules that are connected, whether it is an output module, whether it is the input module, whether it is the processing unit. On each and every part of the PLC, it needs some power supply. That power supply could be AC, could be DC. So if from the output side we provided the AC power supply, then it is having rectifiers, filters, and all those stuff inside, so that it could convert it into DC. Whenever there is any module which needs the AC supply, the power supply will provide it the AC signal, and if any module needs the DC supply, then constant DC supply will be provided by this power supply. This only power supply section is having all the options with you, that we can provide AC or DC to different modules of the PLC that are being utilized inside, right? Then after, let's talk about the CPU. The CPU is basically a processor module. It is a processing module. It does all the processing functions, the arithmetic, the logical, the all the processing functions, all the processing systems, the things that as we do in our PCs. Similar is with this specialized computer specially designed for the industrial purpose, right? So this CPU reads the instructions. What is the function of the CPU? Is it reads the instructions, it stores the result in the memory, right? It gives the instructions to the memory that what kind of a data to be stored, what is the input, what is the output, what the processing is to be done inside. That is all controlled by this CPU. All the storing part is done by the memory, but the instructions to the memory are given by this CPU. All the instructions will be given by this CPU. It reads the programming instructions, the input data, and it moves it to the memory required, right? Then after there is a COM port. COM port means the communication port. It is a kind of a port that will be connecting your input and output modules with each other for the communication purpose. Then after there is a memory. What a memory will do? Memory will hold. It will have something in it. As we all know that what a memory does, it holds the systems, right, or the system software. So what does memory does here is memory will hold the system software. It will hold the user programs, whatever the programs the user is making, everything will be stored in the memory. Then the program data, then whatever the data is being utilized inside the program by the user is being held by the memory, and the results of the system that the program is being made, right? Everything, the system software along with the program data, along with the user information, along with the data, along with the result, everything will be stored in this memory. And last but not the least, the programming device. This is the most important portion. This programming device is connected externally to the PLC. As you can see, it is not the part of the PLC block. It is used externally. It is connected externally so that it could be used to program not only a single PLC but to program any PLC, any other PLC also that is being connected, because in an industry there will not be a single PLC for the control purpose. There will be a lot of machines, and all the machines or most of the machines who need programming will be having PLC inside them, and whatever the machine will be having PLC, they need the programming device. So we don't need to purchase different programming devices for all the machines, so we can share this programming device. That is why it is made external to this PLC, so that it could be utilized in each and every PLC that is being used in a single industry, or we can have one or two depending upon the requirement or depending upon the number of PLCs that you are using in an industry. Then this programming device can be handheld programming device, it can be industrial terminals, and it can be personal computer even, which can be used as a programming device for this PLC, right? So let's I hope you all are clear with the building blocks of the PLC. What is the function of the input module, output module, the connectors that are being utilized, the inputs you are using here, the outputs you can be connecting. Then what is the function of the power supply, the function of the CPU, memory, communication port. I hope you all are clear with all this, right? So let's move on to the advantages of PLC, right? So if I will talk about the advantages of PLC, then I hope I have cleared you, as earlier even in this lecture or in the previous lecture we have discussed about the advantages of PLC. First thing is the flexibility, that it is not rigid. Rigid means it is not a hardwired system. It can be changed. As we all know that whenever the programming is done, then it becomes a flexible system, that if our one program is not working, or in other case if we need to change the input, or we need to change the number of outputs, or we need to change something, or some machine has been changed, or the scenario has been changed, or the technology has been upgraded in any kind of option, in any kind of proportion, our PLC will be flexible and it could be utilized different manner, so in a controlled way of through softwares, right? Then is pre-testing, second advantage. First advantage was flexibility, second advantage is pre-testing. Our PLC is not always necessary that we have to program it, and then we will install it into the machine only, and then only we can test that whether it is working or not, because we cannot take risk with the machines, because the machinery that is being utilized in the industries, it is very costly, it is very expensive. So we could not take any risk with those machines by giving experiments or by taking experiments with that machine. So that is why there is a huge advantage of this PLC, that we can use pre-testing. So while pre-testing, we can use the PLC in the labs. If we will use the PLCs in the labs, then what will happen if there will be any error, or if there will be any logical problem, or any kind of a problem at the output, or if we will not be getting the desired results that we want from that PLC or that particular program or that particular machine in which you have to install that PLC program, then what you can do is you can pre-test and correct that problem in the earlier stage before implementing it into that machine, right? So what it will do, it will save your machine from damaging. That is why it is an advantage of the PLC. Next advantage is the space requirement. It is a very small kind of an equipment that could be used anywhere, and it can be placed anywhere, so it doesn't require any much space in that. Then reliability, it works for more and more time, it is having less wear and tear problems, it doesn't need any kind of more maintenance, right? So it is more reliable as compared to the mechanical and relay control systems that we used earlier. Then after the maintenance, as I have already told you, then the power consumption is there. The power consumption is very low because it requires very less power for the functioning of its purposes, for the functioning of its different panels, right? Then after installation, its installation is also very easy, and the programs can even be entered on the factory floor by anyone who can understand the ladder programming, who will be understanding the ladder programming, that can do the programming of the PLC. So it is very simple, right? Simple to install. Then physical components like timers and counters and sequencers and master controls, relays, they are all implemented using software. So no physical device like timers, counters, or like sensors or sequencers, the sequencers or master control system, we do not require anything, as all the functions of these kind of devices will be done by the software itself, right? Then is the speed of operation. Then the PLCs could do work at a higher speed. The PLC programming and the logic operation is determined, and the scan time is very less, and the processing time and the working time is very less. The processing time is in milliseconds, so that is why the speed of operation is very high. Then the complex system designing and sequencing, right? So if even there will be any complex systems in complex machines that we have to do, or we have to do any complex task for controlling the robotic arm, or to pick and place something, and then to pick and place again, and then pick and place it onto another part, in the top part or the down part or anywhere, or what kind of any kind of the robotics or any kind of the complex machinery that you have to control in the PLC, it becomes very easy to design it, and even the complex systems could be designed very easily in case of the PLC, they can be controlled. And there is another advantage, that is remote monitoring and control. Remote monitoring means we can control it from a distance also. We can control the advanced PLC based control systems, they are easily monitored and controlled from anywhere the world using the internet services. If we will connect any internet device along with our PLC system, then we can take care of that system from anywhere from the world. If we are not present nearby the system, then even we can control that. So this is the biggest advantage of our advanced PLC control systems, and then after at last the advantage is debugging. So with this we are having total 12 advantages that I have listed you today about the PLCs. You can find more also, okay, if you want to. Then the debugging means it is very easy to trace out the problems, if any, in the PLC based control system whenever we are doing the ladder diagram programming. So in advanced PLC systems, an operator message can be programmed for each possible malfunction, right? So means an operator message will be provided that there is a problem at this particular line or at this particular stage, so you can handle this, you can correct it. So debugging and testing is very much easy in case of the PLCs, right? So this was all about the building blocks and the advantages of PLC. In the next lecture we will be discussing about the PLC's programming languages, that what kind of programming languages we will be using, and along with that we will be discussing about the applications, that practically in which kind of industries specifically the PLCs can be utilized. So thank you so much, students. Thank you so much for today.